Yes.
So let's try and do let's try and do this one. I said now there's one thing that has to be learned, and that is there's certain types of questions, and I'm going to just quickly go over them. Okay, certain types of moles questions related to gases. So let's quickly go over them. So we can talk about moles and gas volumes just a little bit more. Now, remember one thing about moles and gas volume. As a moles and just a second, so moles and gas volume. Just hold on a second. Let me just say it. So moles and gas volume. Now, what happens in moles and gas volume is that you need to learn that when everything in an equation are gases. For example, there's nitrogen gas and there is hydrogen gas, and they're reacting to form NH3 gas. So the ratio is one molecule reacts with 3 molecules and produces 2 molecules. Now, in that case, if you're given the volume of one of the gases, let's say I'm given that this is 1000 cm cube. Then remember, mole ratio and volume ratio of gases is the same. And the volume ratio of gases is the same. It's kind of the same. So what that means is that if one molecule of gas reacts with 3 molecules of this other gas, then 1000 cm cube would react with hydrogen gas in the same ratio. It's going to be 3000 cm cube of this gas. You don't need to find moles. 3000 cm cube 3:2. That means the amount of ammonia that would be produced in the same exact ratio. So for this, listen to this carefully, that mole ratio and volume ratio of gases is always the same. And you can even calculate the moles. Like this is 1000 divided by 24. This is 3000 divided by 24. It is going to come out to be 1:3. So if you're given any gas and the equation only contains gases, you don't need to find moles. Here's another one. I've got H2 gas reacting with Cl2 gas, and they're producing 2HCl gas. So the ratio is 1 reacts with 1 and produces 2. So if you're given the volume of one of the gases, no need to find moles. There's no need to find moles. Can somebody tell me quickly what's the ratio, like 1:1? So what is the volume of gas what is the volume of Cl2 gas over here? What would it be?
500.
So this is going to be 500 cm cube. And according to the same ratio, this would be, I think, 1000 cm cube. This would be twice the amount. So for gases, things are really easy because you don't need to apply the formula. You don't need to. You could have done this other way, the longer route. What's the longer route? The longer route is, like, if somebody's asking you to find the volume of Cl2 gas or HCl gas, the longer route is you find the moles of H2 gas. For that, you would have to divide that by 24,000. Right? And if I take out my calculator and try and do that, it's going to be 500 divided by 24,000. I think that's it. And that gives me 0.20833 moles. So I'm going to write, okay, I'm getting 0.208 moles accurate up till 3 significant figures. Then using moles, I'll find the ratio of this one, which is double that amount. So if I double that, I'm going to multiply that by 2. I'm going to get 0.041. It was actually 0.0208. Just a second, let me correct this. This was 0.0208. I double that, I find the moles of HCl, which are coming out to be 0.0417 moles. So this is coming out to be 0.0417 moles. Now I have the moles. I multiply by 24 dm cube to find the volume, or 24,000 cm cube to find the volume in cm cube. If I do that, what do I get? I'll multiply that by 24,000 and I get 1,000. So after doing all of that calculation and using all those moles formulas, I mean, what's the point? It's simple. The question is going to be very simple. Don't find moles. No need to find moles. For gases, the mole ratio and volume ratio is going to be exactly the same. So is this point clear to everyone? Mars clear? Oswa, Ahmed?
Yes, sir.
Okay, Sidra, is this clear?
Yes.
So next time you see gases, the question is really simple. Here's another one. Quickly tell me, like, I've got N2O4, it's decomposing to form 2 NO2s. I've been given let's say 4,500 cm cube of N2O4 gas. Now quickly tell me what's the volume of NO2 that's going to be produced. What is it going to be?
9,000.
Okay, so that's going to be 9,000. Because it's 1:1. I mean, it's simply 1:2, that's it. So it's going to be 9,000. That's it. So the question is very simple. Don't bother finding moles. So here's a question. And the question says, now you have to be very careful with these questions. The question says all of these are gases, except for, and remember, I mean, the thing that I just taught you, that's only for gases. Mole ratio and volume ratio is going to be exactly the same, but only for gases. If you're comparing gases, that's it. Water, remember, is a tricky thing. Okay, make sure whenever an equation has water, make sure what are the conditions? Is water a liquid, or is water a gas? So over here, they're telling us that it's cooled to room temperature. So that means water must be a liquid. So water is not a gas. Okay, so you have to be careful. What are the conditions? If you see room temperature, then you should know that water would be in liquid state. The other ones are gases. I mean, you've got oxygen gas, you've got carbon dioxide gas, SO2 gas, you've got this methane thiol gas. So you've got all of this. So you're saying 10 cm cube of methane thiol, which is this one, is exploded. It's burning. Quickly tell me how much oxygen would be used up. I mean, what's the ratio? 1:3. So how much oxygen? What's 30. The what? Okay, so that's obviously going to be 30. Okay, that's correct. And how much carbon dioxide? That would be 10, right?
10.
And this would be 10 as well, right? And water is a liquid. So he's asking for the final volume of the resultant mixture of gases. So we can kind of ignore water, because water is not in gaseous state. He's asking us the volume of gases. So we can just remove water. So now we have to be careful. So what is the final volume of the resultant mixture of gases? So what am I getting? What are my products? My products are, if I write down my products, I've got 10 cm cube of CO2. And I've got 10 cm cube of SO2. Those are the products that are forming resultant mixture of gases. But remember, he said that he was reacting it with 60 cm cube of oxygen. But over here in the equation, only 30 are actually taking part in the reaction, because methane thiol needs only 30. It's 1:3, so it only needs 30. So that means your oxygen was in excess. You added too much of it. So how much oxygen would be left at the end of the reaction?
30 cm3. 30.
30, because out of the 60, only 30 are actually taking part in the reaction. So the final mixture or the resultant mixture will have your products, but it will also have the leftover oxygen, which is 30 cm3. So the final mixture of gases would be the products that are produced plus the leftover reactant, which is O2. So it's 10 plus 10 plus 30, that would be 50. So the answer is going to be 50 cm3. Is this question clear? Reed, is this clear? Waspa, Sidra, is this clear?
Yeah.
ठीक है, Mars, is this clear?
जी सर सर ये लेफ्ट ओवर एंड प्रोडक्ट्स में आएंगे ना ये जो CO2
हाँ, क्योंकि उसने he's not saying find the volume of the products. He's saying find the volume of the resulting mixture of gases. So the end product is that you'll have your products, but there's going to be leftover oxygen as well. So the resulting mixture of gases would also include the leftover oxygen gas as well in this case. So the next question is going to be which one? Just a second. This one is kind of similar. Now he's saying that there's 10 cm3 of carbon disulfide and it's burned with 50 cm3 of oxygen. So kind of similar, 10 cm3. So according to the ratio, you just need 30 cm3 of O2. And according to the ratio, 10 cm3 of CO2 would be produced and 20 cm3 of SO2 would be produced. So the question states, first thing, he added 50 cm3, so only 30 is actually taking part in the reaction. That means the very first thing is 20 cm3 of oxygen would be left over. It's going to be left at the end of the reaction. Is this clear? Okay, you added 50, but the equation suggests that only 30 would react. Okay, so is that clear?
Yes.
I said then after measuring the volume of gas, the product was treated with aqueous NaOH. And I said, what else would you have? You'll have the leftover oxygen plus you'll have your products that are being formed. I mean, those are your products that are being formed. So there's 10 cm3 of CO2. And there's 20 cm3 of SO2. So you got these two things also being produced. Now he's saying the products are treated with excess sodium hydroxide and the volume of gas measured. So volume of gas after burning, it's going to be 10 cm3 of CO2, 20 cm3 of SO2 that's produced, and the 20 cm3 of leftover oxygen. So that would be 20, 10 plus 10. That's going to give you 50, right? So after burning, it's going to be 50. And the volume of gas after adding NaOH. So can anyone guess, like, if you add NaOH to the resultant mixture of gases, which of the gases are going to react with NaOH? Is it going to be O2 or CO2 or SO2? Which one? NaOH is a base. So which one do you think are acidic gases out of the three? Okay, anyone, any idea which of these gases are acidic? Is oxygen acidic? I mean, we breathe in oxygen all the time. Mars, is it acidic?
No, CO2, I think so.
Non-metal oxides are acidic. Carbon dioxide is acidic. Sulfur dioxide, it makes sulfuric acid when you dissolve it in water. So that's also acidic. So these two will react with the NaOH. So the resultant mixture of gases, the NaOH, if you add an NaOH volume of gas after adding NaOH, it will only contain oxygen. And that's going to give you 20 cm3. So it's going to be C. So before adding NaOH, the resultant mixture of gases had oxygen, they had CO2, and they had SO2 in it. And once you added NaOH, now the CO2 and SO2 are gone. So the only thing that's left is oxygen. So that's 20 cm3. Is this question clear? Clear? Yes or no?
Yes.
So the next one, kind of similar. There's 10 cm cube methane, 10 cm cube ethane, and that's sparked with an excess of oxygen. So they're burning it. They're burning methane, which is CH4. This is the reaction. Whenever you burn a hydrocarbon, you get CO2 plus. You also get water. And you've got ethane as well, which is C2H6. Whenever you burn that, it produces CO2 plus H2O. So plus H2O is produced. Now, you can balance it. It's going to be 2 CO2s and this is going to be 3 H2Os, and the amount of oxygen would be 4 plus 3, that's 7, I think. So it's going to be 7 by 2. And you've got over here, it's 2 H2O and 2 O2. But anyways, 10 cm cube. He's saying they were burned, and after cooling, the residual gas was passed through potassium hydroxide, which is an alkali. So what volume of gas was absorbed by the alkali? So he's again talking about the carbon dioxide gas, because that's the only acidic gas. Remember, non-metal oxides like nitrogen oxides, phosphorus oxides, sulfur oxides, carbon oxides, they're all acidic because they form acids. So he's saying what volume of gas measured, what volume of gas was absorbed by the alkali. So we're going to first find out how much carbon dioxide is produced. 10 cm cube. So the carbon dioxide amount would be 10 cm cube. If 10 cm cube of ethane is burnt, the amount of carbon dioxide that would be produced would be 20 cm cube. So what's the total volume of carbon dioxide that's being produced? And this is the volume that would be absorbed by the alkali when you add the alkali to it. So that's 30. So the answer is going to be C. So is this clear as well? So yeah. Yes or no? Is this clear?
Yes, sir, it's clear.
अच्छा और क्या है कि अच्छा we can try and do this one. This one was a tricky question as well. It's propan 1-ol, and he's saying propan 1-ol is burnt completely. So there's complete combustion happening, and you've got propan 1-ol. Propan 1-ol is C3H7 and which you burn it and it produces CO2 and water. So that's propan 1-ol. And you can balance it. It's going to be 3 CO2s and it's going to be 4 H2Os. And you got a total of 3 into 2, 6, 6 plus 4, that's 10. So over here, it's going to be 9 by 2, or you can call it 4.5. So anyways, the thing is, he's adding 12 dm cube of oxygen. And he's also adding 0.1 moles of propanol. And he's saying, what is the final volume of gas measured in room conditions and temperature? Now, remember this, I told you when we were doing limiting excess, if you're given 2 moles and you want to find the moles of carbon dioxide in water, which one do you use? This one or this one? You're going to use the limiting reactant. So first try and find the moles of this thing. Its volume of gas divided by 24 dm cube. If you do that, I think you're going to get 0.5 moles. Is this clear? 12 dm cube is 0.5 moles. Is this clear? Yes or no?
Yeah.
So you're going to get 0.5 moles. So how did we do limiting and excess? We did, I do remember doing this on the board. Just a second. He had no idea where the board went. Just a second. Okay, just okay, I think we. Anyways, the board has hung up. It's as I told you a simple trick of finding which one is the one that's in excess. I mean, over here it's kind of obvious as well. Like it's 1:4.5, right? So if it's 1:4.5, so what would 0.1 react with? How much oxygen would be needed? Can you even just mentally tell me like it's 1:4.5? So if you've got 0.1 moles, then 0.1 moles according to this ratio would react with 0.45 moles. Is this clear? You can use the ratio 0.1 divided by 1 into 4.5. That would give you 0.45 moles. So you don't need 0.5 moles, you need 0.45 moles. 0.5 moles is in excess. Is this point clear?
Yes.
Okay. I mean, the other thing that we did was, so we did do limiting excess. In limiting excess, I told you that you don't use the excess moles. Like if you're given 2 moles, 2 quantities, as the simple thing I told you was divide the moles by its ratio, divide the moles by its ratio. Whichever number comes out to be the bigger one, that's the one that's in excess. You just cut it out. Don't use that. All moles in the calculation would be calculated using these moles over here. Okay. So all moles in the calculation would be measured using the moles that are over here. So आप ये वाले moles use करोगे. So the thing is, okay, you could have done that as well. 0.5 divided by 4.5, 0.1 divided by 1. This would come out to be the bigger number. You cut it out. DK, don't use that. That's an excess. Because according to the ratio 1:4.5, 0.1 will react with 0.45. So all calculations would be done. So you could have used the trick. Let me just use that trick so you can take the moles divided by its ratio. Take the moles of this substance, which were coming out to be 0.5 moles, divide it by its ratio, which was 4.5. This thing came out to be the bigger number, so you just cut it out. Don't use this. Don't use these moles over here in the calculation. Is this point clear? Clear?
जी सर सर क्लियर है सर, लेकिन ये तभी होगा ना जब मतलब हमारे दोनों मतलब प्रोडक्ट साइड वो रिएक्टेंट साइड पे अगर हमें दोनों के मोल्स हो, अगर किसी प्रोडक्ट तो तब नहीं कर सकते हम लिमिटिंग वाला.
हाँ, मतलब प्रोडक्ट में यू कांट डू दिस. ठीक है, प्रोडक्ट में तो करना ही नहीं है. ठीक है, वो तो सिर्फ मसला आएगा कि अगर एक रिएक्शन हो रहा है, ठीक है, और उसमें ना usually you're given just 1 moles. ठीक है, so if there's a reaction happening like this answer reaction, you've got NaCl वाला कर लेते हैं. ठीक है, it's Na plus Cl2, so it's 2 Na and they're forming 2 NaCls. तो अगर तो एक ही दिया हुआ है, ठीक है, if only one of them is given, फिर तो there's no issue. Like if 0.15 moles is given, I mean, you don't have a choice. You just have to use that. Iske moles, find this moles. You're going to use these moles, okay? But what if they gave you these moles as well? That this is 0.10 moles. So how much NaCl would be produced? Now there's a question mark. Whose moles are you going to use? Which one are the correct moles out of the two? So can anyone quickly tell me which out of the two would you use? Which one is in excess?
Sir, Na is in excess.
N is not in excess. The shortcut is take 0.1.
Oh yes, sir, I got you. So we divide by 2 कर लेंगे.
ठीक है, take 0.10 और उसको divide by 1. So I think this comes out to be the bigger number. So you're not going to use these moles.
Yeah.
And this is also clear as well, because if it's 2:1, so 0.15 will react with 0.075 moles. According to 2:1. So आपको ना you never needed 0.1 moles. to begin with. You just needed 0.075 moles. So that's why this is the wrong moles that were added. You added too much of it. So these moles are never going to be taken or used in your calculation. Is this clear?
Yes, sir.
ठीक है. तो यहाँ पे ना इस question के अंदर the whole issue was कि he gave you the moles of both things, and you had to find the moles of carbon dioxide. So you were confused whether to use these moles or these moles. So we just did that trick. 0.1 divided by 1, 0.5 divided by 4.5. I got this as the bigger number, so I just cut it out. Okay, I'm not going to use this. All calculations would be done using this. It's 1:3, so it's 0.1 ratio. This is going to be 0.3 moles, right? And the amount of water would be 0. It's going to be 0.4 moles. Now the question is, he's asking about the final volume under room conditions. So water is not a gas. So he's asking for the final volume of gas. So the volume of gas that's going to be produced is going to be carbon dioxide. So what's the volume? The volume would be moles multiplied by 24 dm cube. And that gives you 7.2 dm cube. But remember, he's not asking about the volume of the products. He's asking just the volume of the gas. So is there some oxygen left over as well? How much oxygen is left over? I mean, you add
0.5.
0.05. Well, you added 0.5. 0.45 got used up according to the ratio, 1:4.5. 0.45 did get used up. Piche kya bacha? 0.05. So there is 0.05 moles of leftover oxygen. So usko bhi agar if you multiply it by 24 dm cube, you're going to get what? I think 1.2. Is it 1.2?
Yes, sir.
So iska matlab hai there's some leftover oxygen as well. So the final answer would be 7.2 dm cube of carbon dioxide that's produced, and wo jo bachi hui remaining leftover oxygen, that's going to be part of it as well. So the total volume would be 8.4 dm cube, because there's going to be 1.2 dm cube of leftover oxygen as well. Is this question clear? Clear hai?
Yes,
जी सर.
आ देंगे.
क्या चीज?
तो लेफ्ट ओवर जो अभी आपने बताया ऑक्सीजन का.
नहीं, वो क्लियर है कि 0.5 मोल्स एक्सेस में था, वो तो क्लियर है ना?
जी सर, वो क्लियर.
तो 0.5 में से कितना रिएक्ट कर रहा था? मतलब 0.5 सारा तो रिएक्ट नहीं कर रहा था ना, मतलब हमने तो 0.5 मोल्स काट दिए थे ना, क्योंकि 0.5 मोल्स वाज इन एक्सेस. 0.1 मोल्स यूज कर रहे थे ना, इससे रेशो लगा रहे थे. 0.1 मोल्स अकॉर्डिंग टू द रेशो 1:4.5. इक्वेशन में रेशो क्या है?
1:4.5 यूज हो गए थे.
तो पीछे कितना बचा? तो 0.05 मोल्स बच गई. तो आपका जो फाइनल वॉल्यूम ऑफ गैस होगा ना, उसमें खाली प्रोडक्ट नहीं होगा, देयर इज गोइंग टू बी वो जो लेफ्ट ओवर ऑक्सीजन, दैट वुड आल्सो बी पार्ट ऑफ इट. सो 0.05 मोल्स मल्टीप्लाइड बाय 24 dm cube, दैट गिव्स यू 1.2 dm cube. तो ये भी बीच में होगी. तो टोटल वॉल्यूम ऑफ गैस वुड बी 8.4. ठीक है, क्लियर है?
जी सर. सर और आपने कभी क्वेश्चन जो ऊपर करवाया था, क्वेश्चन नंबर 1, सर उसमें हमें जैसे 2 दाने वॉल्यूम्स दिए हुए थे, तो उससे भी तो हम ऐसे कर सकते हैं ना, वो भी तो लिमिटिंग और एक्सेस ही है. उससे भी हम वैसे, अगर वो लंबा मेथड होगा, जब अगर हम
कौन सा वाला? ये वाला
सर, इससे ऊपर वाला.
ये वाला?
जी सर, देखिए. जी
हाँ,
सर,
ये भी लिमिटेड और एक्सेस वाला ही है कि 10
इसको
cm.
हम वाले मेथड से भी कर सकते हैं ना, कि मोल्स निकाल के भी पता कर सकते हैं कि मतलब कौन सा, वैसे तो सामने से पता चल रहा है हमें.
हाँ, वो तो पता लग रहा है कि हाँ, तो वो भी कर सकते हैं, लेकिन रिमेंबर मोल रेशियो वॉल्यूम रेशियो सेम है. तो अब ये वाला मेथड ना वॉल्यूम के ऊपर डायरेक्टली लगा दो, क्योंकि मोल रेशियो वॉल्यूम रेशियो तो सेम है. तो मतलब अगर ये 10 दिया हुआ है और ये 50 दिया हुआ है ना, तो आप 10 डिवाइड बाय इसका रेशियो जो कि 1 था, 50 डिवाइड बाय इसका रेशियो जो कि 3 था, किसका बड़ा नंबर आ रहा है? मतलब इसका रेशियो 3 था, इसका रेशियो 1 था, तो वो यही आ रहा है ना बड़ा. तो इसका मतलब है 50 जो है ना वो एक्चुअली एक्सेस में था. तो आप 10 cm क्यूब से सारी कैलकुलेशन करोगे. इज दैट क्लियर?
जी सर, थैंक यू सर.
अच्छा, सो अब ये क्वेश्चन भी हो गया. सो नाउ वी मूव टू एक और टाइप का क्वेश्चन है, एंड दैट्स नोन एज कंबशन एनालिसिस. उसको पहले उधर कर लेते हैं, ठीक है? सो दिस इज, जो अब हम क्वेश्चन करने लगे, दैट्स अ वेरी स्पेसिफिक टाइप ऑफ क्वेश्चन. ठीक है, इसके अंदर अलग से एक पेज है, वर्कशीट के अंदर भी, ठीक है, there's a separate section for that. And मेरे ख्याल से it's a very favorite question that क्योंकि even in the worksheet there are lots of questions on this one, on this type of question, ठीक है. अच्छा, that's known as combustion analysis. तो अभी फिलहाल I'll just give you what combustion analysis is. Just a brief idea. So combustion analysis. Now the whole point is that the biggest branch of chemistry is organic chemistry. Why is it the biggest? Because we are organic. Okay? Carbon compounds are everywhere. I mean, we are carbon compounds. Every cell in our body is a carbon compound. Our hair is a carbon compound. Everything, cell, red blood cells, white blood cells, DNA, RNA, mRNA, okay, everything, your pores, etc. They're all carbon. I mean, all living organisms, okay, plants, animals, etc. Everything. They're all carbon compounds. So, and fossil fuels are made out of it. So all fossil fuels are also carbon compounds. So whenever you have a hydrocarbon or an organic compound, the biggest question is you need to find out how many carbons it's got, how many hydrogens it has. Okay, that's one of the biggest questions. Okay, remember, if you find an organic molecule, okay, the problem is, like, let's say you pick a leaf. Now, by looking at the leaf, you don't know what it's made up of, how many carbons it's got, how many hydrogens it's got, okay? So what you can do is you can burn it, and you can analyze it. When you burn a hydrocarbon or any organic compound, usually two things are produced. One is carbon dioxide and the other one is water. Now, depending on the formula of the hydrocarbon, so you could have many different types of hydrocarbons. It could be CH4. So the amount of oxygen that gets used up and the amount of carbon dioxide that's getting produced, it's always going to be different compared to the other hydrocarbons. Let's say I pick another hydrocarbon and I try to burn it. Let's say I have C4H10. If I try to burn it, the amount of oxygen that's going to get used up, the amount of carbon dioxide that's going to be produced, and in this case, it's going to be 4 carbon dioxide and it's going to be 5 H2Os. And the amount of oxygen that's going to be used is 8 plus 5, that would be 13 divided by 2, right? So the point is, by just analyzing the amount of oxygen that's getting used up and the amount of carbon dioxide and the amount of water that's getting produced, you can kind of get an idea of what the formula is. Okay? Because every hydrocarbon has this unique ratio in which it burns. Okay? I mean, you pick two different hydrocarbons, they would all have a different ratio of the amount of oxygen getting used up and the amount of carbon dioxide getting produced and the amount of water that's getting produced. For example, in this case, it's going to be 2 carbon dioxide and 2 water molecules. And the amount of oxygen that's going to be used is 4 plus 2, that's 6. So it's going to be 3 O2. So you can kind of guess the formula. TK, for example, you burn it, like this is unknown. You burn it, you get 30 cm cube of oxygen is reacting, and 20 cm cube of carbon dioxide is being produced, and 20 cm cube, let's say, water vapors are being produced. So you're pretty sure that it's going to be C2H4. So is the idea clear? The logic behind combustion analysis, is this clear?
Yes, sir.
Okay. So is this clear? I mean, you don't know how to do this, but the idea is that every hydrocarbon burns in a unique way. Every hydrocarbon has a different ratio of oxygen, carbon dioxide, and water. And if you know that ratio, you can kind of figure out the formula of the hydrocarbon, the unknown hydrocarbon. So that's what we're going to try and do. And we're going to try and figure out, how do you figure out this formula? By just looking at the ratio of oxygen and carbon dioxide in H2O. Okay, example is, if you don't know what this is, if you don't know what CH4 is, by just looking at the ratio, how can you figure out that it's got 1 carbon and 4 hydrogens? If you don't know it's C4H10, by looking at the oxygen and carbon dioxide and water, how can you figure out what the formula is? Okay, so we'll do that in the next class then. Okay, we're running out of time, so we can do that one in the next class. Okay. चलिए ठीक है, लेट्स कंटिन्यू टुमारो देन। सही है, क्लियर है? पिछले वाले में तो कोई क्वेश्चन वो प्रॉब्लम नहीं है
सर।
हाँ जी।
सर ये कंबशन एनालिसिस मतलब ये इक्वेशन दिया होगा हमें या फिर हमने बनाना होगा?
नहीं, ये तो अभी हम सारा करेंगे ना, ये भी हम करेंगे, मतलब वो सारा भी डिस्कस करेंगे। अभी तो आइडिया क्लियर हो गया ना कि करना क्या है, मतलब
जी
वो
सर।
करना कैसे है वो भी हम फिगर आउट करेंगे। ठीक है,
ओके।
चले, ओके, अल्लाह हाफिज।
ओके सर, अल्लाह हाफिज़।